Hello everybody, welcome back to our channel. Paper 3, now we move to option B, engineering physics. Question 8, it is also in the new 2025 syllabus, so our new friends, okay? Year 1 student, okay, still a little work on it too, okay? It's a good question for us to practice the HL parts, okay? Okay, first of all, you talk about, don't look at all the things, look at the question A1. Outline what is meant by moments of inertia. That's it, okay? No need to look at the context, okay? Just a textbook problem. Definition, okay? What is the definition of a moment of inertia? Remember, moment of inertia is like the mass, right? But we are in an angular thing. So remember, moment of inertia, it is the tendency to resist what? Not acceleration, angular acceleration. So this is the answer. It is the tendency to resist angular acceleration. And then state the condition for rotational equilibrium. You remember there are two conditions for equilibrium. One is translational, one is rotational. Remember, answer it in a technical way. Okay. So remember, what is the requirement? Yes, let not moment. Okay. We have to say torque. Okay. Let torque equals 0. Very similar to that in translational equilibrium. Net force equals 0. So say it is enough. Okay. For the third one is hard. Okay, so that one cylinder like this, they give the moment of inertia is 112 ml square. It will be given to you. You don't need to remember anything except mr square for a point mass. Okay. So he said that two identical cylinders joined by end to end, and then moment of inertia when the cylinder are rotated about their combined center. So you need to really draw it out. Okay, another one. Okay, another one. So you have this cylinder here. So now you have another one joining end to end. Okay, and then they said that the axis is not at the original center. Now it's at combined center here. So this is the new axis. Okay, so you have to think about what is the change. Okay, yeah, I shift down the axis by not L, half the L, right? It is L over 2. And then first of all, I have to remember for one cylinder, what is the new moment of inertia, and then multiply it by 2 will be the combined system's new moment of inertia. And you remember when I shift down by a distance A, the change is at ma square, right? The total mass. I should use a calculator. And now this A is L over 2. So the calculation is here 2 cylinder, original 112. But now you shift from down by L over 2, and then m L over 2 all square. And then you can use the calculator to some calculation. Just get the ml square. So 112 plus 1 over 2 all square. You get it. Yes, it is 1 over 3. So maybe you can do it slowly because it is given by the question, the answer. So you have to do it slowly, give some steps, quote unquote. And then you show it is 2 over 3 ml square. The marks, I think, is on the first part here, okay? Although it's a little bit mean, just 1 mark, okay, but yeah, still work hard on it, okay? You got it? Well done.